All right. Hello again, everyone, to the second day of the Computational Social Sciences Summit. And for the opening session of this day, we have Merih Angın with us. Merih Angın is an assistant professor at Koç University and a graduate of Bilkent University. Welcome, hocam. Thank you for accepting our invitation. We are lucky to have you here. Thank you for making time for us. And without taking further time, I would like to give the stage to you.
Thank you so much. Well, I'd like to thank you for inviting me for the second time. Actually, it's my second time now. It's an annual summit. I'm glad to see that. Well, good afternoon, everyone. It's great to see you, even though virtually. Maybe at some point this turned out to be an in-person summit as well. We'll see how that goes, I guess. It is indeed a great pleasure to be here with you all today. As Omar said, I also happen to be one of the alumni of Bilkent Economics Department. And it's always a great pleasure, of course, to be, even though virtually, back at your alma mater. And today I will present to you what I consider a very exciting project. It's part of a research that we are conducting at MA-CSSL. With that, let me share my screen with you. I hope you can all see it now. So the project, it's very exciting, is actually at a very early stage. So rather than presenting something that is close to completion, I decided to present a project that is, again, at a very early stage in our lab, in order to also gather some thoughts and feedback from you, because it's a very diverse group of participants, I assume. And that's where we really actually get really helpful feedback. So I would very much appreciate any thoughts, ideas, comments you'd like to share. Before going into that, though, I also would like to briefly speak about our lab, which is MA-CSSL. It is a computational social science lab, bringing together a diverse group of researchers, ranging from economics, political science, IR, sociology, of course, computer science, historians are also in the lab, lawyers. So we are a really diverse bunch, I would say. We established this lab back in 2019, that's also when I moved back to Turkey. And the lab itself was something I actually pledged to establish as part of the II.Bilkent's 2232 fellowship, which is the international fellowship for outstanding researchers, which brought me back to Turkey. And since our establishment, we hosted over, I think, 90 at this point, students, including undergrads, graduate students, PhDs, and on top of that, we had a lot of senior researchers, again, from different disciplines and postdoctoral researchers. We had the pleasure to fund the study of many of our students as well, thanks to the help of II.Bilkent's fellowship I just mentioned. So with that, we had about 19 ongoing projects, some of which are now, again, coming to an end. And so we are starting new projects. So we are always open to new research ideas, collaborations, and again, students who would like to learn more about computational social sciences, who get training and who also become part of our research. We have a really good track record of getting all these fundings I just mentioned, together with some awards that we also got with our really diligent students, and also have a good track record of placements of our alumni who go to prestigious institutions after having spent some time in our lab. So after this brief who we are, what we do, let's move on to our new project. Again, I mean, even before starting the presentation, I would like to acknowledge the really hard work our students put into this. Everything that I will present to you is actually the product of really hard work of students in our lab, not just myself. So I should acknowledge that before starting. All right, without further ado, let's move on to the material that I will present to you today, which is, again, in a way, the proposal stage of a project that we started in the lab. We did a lot of work to put that together, and are currently waiting on getting some funding to, again, finally kick off. But we did the lit review and initial preliminary work to start this project, which is a very ambitious one and thus requires funding. And so we're waiting on that for now. So the AI ability, uncovering the effects of bias in human AI collaboration with humans in the loop, is the title of the project. And what do we mean by that? I will walk you through that first. So the recent literature on responsible AI has really produced, as we can see, a really rich body of work on the effects of algorithmic and societal bias in AI, which of course exacerbates existing inequalities on the outcomes of automated decision-making in various fields. But the effects of such bias on people's abilities to collaborate with AI, which I term as AI ability, by the way, remains really unexplored. So the word AI ability is not actually a word in English, it's something I coined. It's basically referring to the ability of humans to collaborate with AI. And it doesn't necessarily refer to a particular education level or a particular skill set only. It can range, and I will get back to that later. So the project I will present, therefore, aims to discover how biases in AI systems affect humans' interactions with these systems by taking an approach that has the interactions themselves as the focal point of attention, by having humans in the loop when assessing the effects of a variety of biases. And again, I'll get back to that later. But just as a brief intro, for this purpose, we're aiming to conduct a cross-country study involving participants from 6 different countries in 4 different continents, namely the US, China, Turkey, India, Ghana, and Denmark. All right, so our project will answer 2 questions. I will get to that with a very novel multi-method approach, considering the sociological, psychological, and of course the computer science aspects of human AI collaboration problem with a very interdisciplinary research team. And our questions are, first of all, how does bias resulting from the development of AI systems for specific demographic groups affect the ability of people to collaborate with those systems? And how does bias resulting from cultural values ingrained into the development of AI systems affect the ability of people to collaborate with those systems? So by introducing varying levels of bias in the AI components of serious game software, and that's at the very core of this research, we will develop that for 2 different human AI collaboration use cases. Our project will capture human AI interactions in a comprehensive manner and discover how decreasing or eliminating biases about gender, age, culture, race, ethnicity, and educational background in AI agents affects the ability of people to collaborate with AI. So these are what we are aiming to do with this project. So in relation to these research questions, of course, we formulated some preliminary hypotheses that we will be tested, and we have two core hypotheses with some sub-hypotheses, if you will. First one being decreasing gender bias in AI systems improves AI ability of people unfavored by such bias. And then we apply the same logic to the other types of biases. Second one being racial/ethnic bias. Third one being ageism, so age bias. And then the fourth one being the education bias in AI systems. And then at the second level, we take it up to the international or global level, if you will, and we surmise that decreasing bias in AI systems introduced by the global north improves AI ability of people in the global south unfavored by such bias. So to test these hypotheses, then we will use, as I had said, a novel method, which is serious games, which will allow capturing and analyzing human AI interactions under different scenarios, including, again, varying types and levels of these biases I've just mentioned. So, of course, here we also need to take a step back and look at what we actually aim to do. The overarching aim of the project is to discover how unbiased AI models can improve AI ability. And in that regard, we have some specific objectives that I mentioned here. Well, first of all, of course, detecting gender, age, education, race, ethnicity, and cultural biases in human AI collaboration cases that adversely affect AI ability. And secondly, introducing this novel method, which is serious games that I will speak about in a bit, to study human AI interaction that can be used by multiple disciplines in social sciences. And thirdly, assessing the impact of various types and levels of bias on human AI collaboration tasks, using, again, serious games, to not only show whether biases affect AI ability, but also show how they affect it, which, again, is implemented in our 6 different country cases: the US, China, Turkey, India, Ghana, and Denmark. And then finally, of course, demonstrating how the global north-south divide in AI talent can be reduced through utilizing unbiased models in human AI collaboration. This, of course, very much speaks to the Digital Rights Initiative, which is an initiative that we started with one of our senior researchers at MACSSL, which is, again, an initiative that is looking at the ways in which we can minimize the digital divide between the global north and south. And so they also are part of this project, one of our collaborators, if you will, who will be helping us with conducting all these cases in different corners of the world, which is something I will speak about in a bit. All right. So, of course, before moving on to the research design, I also need to briefly speak about what has been done in this literature on AI and inequality, which is very much, of course, informing our research, and we're, in a way, building the research on that, with the potential of human AI collaboration to, what we could say, dramatically transform so many fields touching people's lives, human AI interactions, and the surrounding problems, including explainability or transparency of AI algorithms, or fairness of AI systems, representation in AI datasets, AI trustworthiness, have started to be questioned by many researchers and practitioners. Couple of citations you see here and there, that's discussed by Koronek et al. In their recent work. The labor-saving effects of AI can lead to increased inequalities and poverty by favoring high-skilled individuals, and countries, of course, leading the progress in AI is one of them. By the same token, Acemoglu calls automation as the handmaiden of inequality, discussing its roles so far in causing the decline in the demand and wages of blue-collar workers, therefore stating that a few key players, which are the usual suspects, the tech giants, are really shaping AI in the world we live in. It is increasingly, of course, recognized that AI systems are reflecting and reinforcing inequalities, particularly along the lines of gender and race, for reasons including lack of diversity in data training, use of biased language and algorithms, which is something you are more familiar with, I'm assuming, and in general, stereotypes and historical discrimination in user behaviors. So biases, therefore, can be identified at several stages of AI systems that relate to modeling, training, and usage, right? And on top of that, algorithmic outcomes trained on biased data can, again, exacerbate the sources of bias through user interaction and therefore creating a feedback loop between data, algorithms, and users. So such concerns parallel, of course, the diversity crisis in the field of AI research and industry. As you may know, women really constitute a very small percentage of for example, participants of major AI conferences. Certainly this one is not one of them, but less than 20% of AI professors and about 10 to 15% of AI researchers, for example, at companies such as Facebook and Google, is really revealing. Similar arguments are valid for the race and ethnicity imbalance in the computer scientist populations, which are developing, of course, AI systems, right? So there is a growing concern, we have to say, around the global impacts of AI on amplifying these inequalities in a nutshell. And we do have some critical work that really discuss the promises of AI concerning the development agenda of poverty alleviation, good governance, social inclusion, pointing out their role in the reproduction of systemic inequalities between the global North and global South. And in this context, we have research arguing for moving beyond mainstream understandings of AI and its biases through locating AI systems in relation to pre-existing social structures and asking how those structures can be reinforced, and replaced if possible. And through ideas from the global South as a source of conceptual alternatives to dominant theories and ethical rationalities of AI is really, again, at the very core of the project itself. We recently actually read the World Economic Forum report on the topic that states that low and middle income countries can be harmed disproportionately by machine learning due to existing inequalities being deeper and regulations being weaker and training data for these algorithms being less available. And looking at the trends in AI, it is possible to say that much of the new wealth created by AI systems will be owned and controlled by corporations based in the United States and China, even though the global South is a major source of human-generated data and should have equitable economic benefits from the tools controlled largely by the global South. So with that in mind, we then did a preliminary work, which is based on natural language processing. Again, that happens to be the favorite subfield of AI that we use at MACSSL. I believe the project I presented in last year's summit was also our NLP work on IMF lending, if I remember correctly. So what we do this time is we gathered all the national AI strategy documents of countries ranging from China to European Union countries to BRICS to African countries, if we found any national AI strategy documents from them, to provide supporting evidence for the concerns that I've just mentioned. For those who are not familiar with NLP, of course, I mean, you probably already got some idea from the earlier presentations, but as a recap, it is basically, again, a subfield of AI that makes human language understandable by computers. It starts with the formation of a corpus stating the rules and associations between words and text. And the process, of course, contains parsing text into a syntax tree, eliminating stop words, stemming the words, and extracting the meaning of the text by using one of the many information retrieval / machine learning algorithms used in NLP. And it is highly useful, of course, for automated analysis of large data sets. So AI strategy documents that we processed using the SDG detector that we have developed in collaboration with my students and UNDP's SDG AI lab, which is a separate work that recently got published in Sustainability Journal. We just applied it to this, and we found that the strongest focus on all national AI strategy documents is actually on industry, innovation, and infrastructure. And many of these documents do not have any mentions of reduced inequalities, which of course then leads us to think that we are on the right track of getting into bias in AI. While scholars, of course, from different fields have addressed biases in AI and related systems with, again, a focus on gender stereotypes in word embeddings for machine learning and NLP, gender biases in word embeddings, as I said, in machine translation, and biases in voice recognition systems is one of them. Facial recognition applications and research engines is another one that has been studied. Gender bias data sets in health and disease also is another. Race biases and algorithm recommendations for patient support is what followed. And we also know gender stereotypes and image search results for occupations that you're probably also familiar with. And again, racial biases and representations of AI in image search results is, again, another popular type of research that has been conducted. Some research is also concerned with perceived biases of AI-based recommendations in terms of race or gender, and perceived fairness and acceptability of automated decision-making systems is another one. Although there is a growing body of work from several disciplines identifying biases in AI and related systems, the efforts for both mitigating biases with a concern for inequality and developing an interdisciplinary approach to this are still, I would say, evolving. And this, in part, I believe, derives from the complexities of what really constitutes a bias, right? Its sources and its relation to inequality, which also, of course, differ across different contexts and for different segments. So in this context, I mean, we also take on board literature from sociology and think that AI systems are not merely technical innovations, right? They're deeply intertwined with society, and such systems are what science and technology studies scholar call sociotechnical, a term that calls attention to how values, institutional practices, and inequalities are embedded in AI's code, design, and use. And this concern has resulted in works on AI and social inequality, addressing the need for further research towards a more comprehensive and disciplinary approach. And in this context, Gurdon et al.'s use a big data process model by analyzing algorithmic decision-making systems in 3 stages, namely data generation, data analysis, and implementation, and they explore the ways in which ADMs produce social inequality in each of these stages. So the definition here is of social inequality is the unequal distribution of valued resources, opportunities, and positions among the members of a population. And their work shows that the stages of data generation, data analysis, and implementation may actually create social inequality in situations where the data used may be biased, the conceptualizations and formalizations of fairness, or may not consider fairness at all, and the inequality outcomes depend really on concrete interactional settings that can result in cumulative disadvantages, particularly for those who have been historically disadvantaged. Therefore, here it is suggested that social sciences can contribute to ADM systems by mitigating biases and studying the context, of course, in a way, designing contextually fair algorithms, accounting for individual characteristics that influence fairness perceptions, and studying human ADM interaction. And again, this rich body of literature on AI bias, which I really tried to summarize in a couple of minutes, has formed a very instrumental background for studying human AI collaboration for us. Nevertheless, keeping human in the loop while studying the effects of bias in human AI interaction has not been the primary objective in any of these studies. So this is what our project aims to remedy, if you will, this gap by shifting the focus back to the actual interactions with humans. So that's where the human in the loop bit in the title is actually coming from. All right, so on to our research design. Our project will, again, make a very major contribution to the understanding of human AI interaction and the effects of algorithmic and societal bias on this interaction, as I said, by employing serious games as a novel method, and the 6 case studies I just mentioned to you with varying levels of AI development, digitalization, and sociocultural diversity. That's where the selection criteria is actually coming from. And by introducing varying levels of bias in the AI components of serious games, simulating 2 different, once again, human AI interaction use cases, I will speak about them in a bit. Our project will test whether, again, decreasing or eliminating biases of different types of AI systems can actually improve the ability of people to collaborate with AI. So I already spoke about the interdisciplinary nature of the project, that it will, of course, involve disciplines ranging from psychology, sociology, computer science. What we're going to do is, so I tried to walk you through how we conduct this research. Again, following our data collection, first of all, bias detection models, which are based on NLP, that will be developed and apply on the collected data. This step will, of course, prepare the data to be used in the development of serious games for each country. And development of serious games for both use cases will be performed in parallel for one country at a time, which will be followed by the conduct of interactive games and surveys in the respective country. I will get into the details of that in a bit. For case selection, as I said, I considered varying levels of AI development as well as diversity in demographics. We use the AI Readiness Index, which is prepared by Oxford Insights. There, the US ranks the first, Denmark is the 9th, China ranks 15th, India is 51, Turkey is 53, and Ghana ranks 92nd. So that gives us good diversity. But high rankings of AI readiness do not always correspond to high AI ability in a country. And a low score does not necessarily mean a country does not have AI ability improvement potential, which is what this research is trying to actually prove with, again, using series games to test that, which I will speak about in a bit. Of course, we will first need to do some exploratory data collection. We will start with secondary data collection, which is pretty much an ongoing process that we are conducting at the moment. But after that, after gathering the necessary familiarity with each case, we'll do snowball sampling to contact experts in the country, the locals, to be interviewed. And the idea is to conduct interviews with these experts. And so therefore, we'll have a more informed primary data collection, which will ensure that the bias detection models actually take into account the key issues in, again, gender, education, age, ethnicity, or racial biases that are emphasized by experts based in the countries the project will study. So that's what we're going to do firstly. Then moving on to bias detection, this part, of course, will again involve an in-depth study on identifying different types of biases, as I had mentioned, and we have 3 stages here. Speaking of the bias detection model development, as I mentioned, there is a growing literature on the development of automated bias detection models for AI algorithms and data. So this leg of the research involves a detailed investigation of existing tools and approaches for AI bias detection, which will also be complemented by the findings of the previous step I mentioned. And so we'll develop automated bias detection models that will operate on textual data. And the primary means of detecting bias in the developed models will be, again, NLP-based processing of the documents that we will be using as input for the AI models in our use cases. Of course, we then have the automated bias detection, and this part will involve execution of the created bias models on the data collected in first part of the research I mentioned. And so the detected biases will form the basis for the development of the biased AI models. And then finally, of course, the bias detection by our researchers. This part will involve manual analysis of the automated bias detection results by our senior researchers in the team, who will be mainly from sociology and psychology disciplines. And the researchers will then check the accuracy of the detection results and complement them with biases identified with our own readings of the collected data in preparation for the development of the bias and unbiased AI model scenarios. So moving on to, of course, the fun part, if you will, of the research, which is series games. As I mentioned, the project will involve series games as the method to, first of all, collect also data and implement our models, the biased and unbiased models, for assessing the effects of algorithmic and societal bias on human AI interaction. While there is, again, a growing literature on AI bias, which mostly focuses on outcomes of utilizing AI-based decision-making systems, studies that are focusing on human perceptions resulting from bias in AI systems are very limited, and they mainly utilize surveys as a method. Of course, surveys are an indispensable, I would say, method for gathering human perceptions about AI systems, but still a more comprehensive, I would say, evaluation of human AI interaction will really require capturing the full history, first of all, of the interactions, including how human actions and decisions are influenced by the AI agents they are collaborating with. So serious games make it possible to capture these interactions in software, and therefore they will be used in our project as the primary method for evaluating the effects of bias in AI on human AI interaction, which will then also be complemented by surveys with our participants. While there are many definitions of serious games today, by the way, it may not come as natural as it is to those who study serious games. We take on board the definition that I think is most relevant to our work, and that is, a serious games as a digital game was created with the intention to entertain and to achieve at least an additional goal, learning or health, for example. And these goals are named the characterizing goals, which can match one or more of the several competence domains, including cognition or perception, or emotion, sensory motor control, and personal characteristics, or social attitudes, or media use. And some important features of serious games are that they allow, first of all, immediate feedback, namely players being able to assess their progress immediately. They can be an important tool for achieving a particular goal when no other alternatives are possible, such as in the case of simulating a hypothetical world. And they always involve, of course, in the case of minor participants, the pedagogy, but that's not something we're concerned about because our research actually involves participants that are over 18 years old. So during the design of a serious game, which can actually be considered as, for those of you who are more familiar with computational simulations, an agent-based model. And that's something I actually did for my PhD. But serious games gives you the flexibility to get, again, immediate results while your participant actually interacts with AI, right? So that's why we chose serious games as a method here. So during the design of the game, all rules of the game, the different characters, their allowable actions, the possible game scenarios and outcomes of actions are decided and integrated into the game logic during the development stage of the game. And during game playing, the users keep performing or selecting among the available actions, of course, which take them through different paths based on actions performed until one of the final conditions of the game is achieved. Can be a task is successfully completed, or the runner runs out of time, or a failure condition is reached, etc. So while also looking at the history of serious games, we know that earlier serious games really involved hard-coded scenarios and deterministic outcomes for each action. More recent games have also benefited immensely from AI components for modeling game flow to provide, in a way, customized experiences to user based on their interactions with the game, basically. And despite the really long, I would say, and widespread usage of serious games in different disciplines and literatures, this project will actually be the first one to use it in assessing the effects of varying levels of bias in human AI collaborative tasks in a multi-country study, of course, making it what I believe a quite innovative methodological contribution to the field. It was actually surprising to me when we first did the lit review for this research. I was, hoping there will be some research that we could build on. Obviously, starting from scratch is always a lot more problematic than doing research that you can build on. But it was surprising to see that the history of serious games is not actually that recent, but it was actually never considered by social scientists like myself to look at human AI collaboration. So that's what we're going to do. And going back to, as promised, the use cases I mentioned, the first use case will involve an intelligent education/training platform. And the second use case will be simulating a job where the user will be interacting with a chatbot to complete tasks requested by the customers/citizens. So, if you remember the very first picture I showed you on AI ability, when we say human AI collaboration, the first thing that comes to mind may be actually an actual robot, right? But robotics is actually only part of that, that field. If anything, humans interact with non-robot bots, right? More often than they interact with physical robots. We all interact with chatbots on a regular basis, for example. So that's where I think we need to focus more on, and that's how we actually chose our use cases accordingly. All right, we have about 15 minutes left, slightly less than that. I still would like to have some time for Q&A. That's where we gather your thoughts, but I'll also would like to briefly speak about, well, maybe we can use that time to gather questions, because I still wanted to speak a little bit about how we will do then our surveys, because that's also part of the second stage of the research. After everyone completes, or all participants, they complete their games, we will also ask questions about their experience about the games themselves. But rather than going into the details of that, I'll rather pause here and open the floor for questions. And thank you all so very much. Please never hesitate to contact me for any questions and comments. If you'd like to meet our lab, please go ahead and check our website. And you can always also email our lab if you'd like to collaborate with us. Thank you so very much.
Thank you so much, Hocam, for this amazing presentation. It was really interesting to listen about and a different approach to AI, basically. So from the audience, you can, if there are any questions, you can, of course, ask or type it in the chat. So, Hocam, I want to go first.
Of course.
How do you think we can use the results, the data, the AI bias data to improve AI, basically?
So what we are, thank you so much for the question. And I really do believe in the importance of doing work with some policy implications, right? And that's clearly what we are doing with this research. The results will actually give us as a pointer towards how we can also reduce these biases. Because the assumption is, and the assumption is actually not only coming from particular disciplines, but we see that, like, particular research in economics would tell us that the current structure or the bias models will always be disadvantaging the unskilled labor. Or, political scientists may be focusing on the global north-south divide, IR scholars as well, right? Saying that it's mainly the global north countries that are developing these models. And so they will always just use and exploit the global south. And so the global south can never really benefit from development of AI, which creates this assumption that AI it's no good for the exploited or the discriminated. We never really question where that is actually coming from. There is not necessarily anything intrinsically biased about AI. AI is developed by the existing biases, and that is the problem. So what happens when we remove these biases, and how these biases can be removed is actually the question that we are aiming to answer. And when in the serious games, we show how the unbiased models can lead to an increase in the ability of people to collaborate with AI, that will also give us a rough idea about how these issues can also be addressed from a scientific perspective. From the policy perspective, of course, that's another question, because that also means that we would need to have the willingness to integrate unbiased models, right? But here the question is how the global south can also, of course, have its own input into the system, because the biases are being fed into the system by those who develop the model. So how these could be used is more kind of a political question. And the answer is just going to be having a more bottom-up approach than a top-down approach, I believe. I am not too optimistic about the ones who already have the power to implement model and develop these models will be willingly giving that power, sharing that power with the less advantaged ones. But there are a couple of different perspectives on that as well. I was actually recently at the Paris Peace Forum, which very much actually focused on this question, and our initiative was part of that too. Some believe that we need more market-based solutions, because the models that we're speaking about are not necessarily developed by states themselves, right? These are the tech giants, which are based in the global north countries that are modeling these, and that's what is really leaving the global south, or again, the segments of the society that is already placed in disadvantaged position, that is being harmed by these developments. So some believe that states should actually regulate AI more and actually tell these companies on how to model and decrease bias. Others believe that it's never going to work and we need market-based solutions for that. Therefore, demand from the global south should, in a way, force or urge these tech companies to reconsider their modeling strategies. Again, that's up for debate. And I'm not saying one is better over the other, but both, of course, stories as will need to be tried and see. I'm not too pessimistic. I'm actually cautiously optimistic, seeing how people's preferences can easily change, looking at the number of users of, like, recently Twitter, for example, or how people can change their preferences in a matter of days. when certain scandals are heard. So making this a more in a way outcome of democratic decision making is going to be part of the solution, I believe. Is a very long answer to a short question. Sorry about that, but once again, I'm really excited about this project and its findings. I'm actually excited to see what we're going to see at the end of the research. So my question is going to be, we're going to wait and see, I guess. I also see Neslihan's hand. I'd like to answer one more question if possible. We still have about 5 minutes.
Hello. Please excuse my turned off camera. Thank you for this great talk. I want to ask you about something. My major is political science and master's degree in MIS is still in progress. It should be clear that video games, VR, and computer graphics techniques are not technologies that have spontaneously and coincidentally derived from DARPA. All this exists today only because of decades of systematic intervention by the Pentagon and the US National Science Foundation and other components in the military-industrial complex. Most of the people who worked in VR at Atari at the time went to work on government-funded VR projects at NASA and various universities. What do you think about this? What do you think about...
And that's the political science perspective, right? Of course, the usage of AI in military security also led to this, exponential maybe increase in the development of AI at the same time. Is definitely one of the driving motives for the United States. And that's something we also work on in our lab for a separate project, the military security economics nexus in AI. And I'm also checking the chat box, and I noticed something from Alberto. You can say the same each time you board a plane. That's true. The question is, of course, again, who is developing and what biases and then are involved?
Exactly.
But I mean, here's the thing. When we say games, like the first thing that really comes to your mind is not serious games, right? The moment I say games, you think of all the games that you've been exposed to since you were a kid. And that's pretty much what I would perceive from a game too. But all these technologies can be used for good. That's what AI for good also refers to. So it's really not necessarily intrinsically about the technology itself, but for what purpose is being developed. And so that's how we are aiming to use serious games for something good, if you will. But of course, I mean, you cannot really ignore the fact that these technologies have been developed by a certain region, again, with a certain segment of the society. The aim of the project is to really show what happens when they don't, when you remove the biases in all the different varying levels and types that I've just mentioned. Is it really true that people with a certain educational background can collaborate with AI better than the others? Combination of these, let's say women who are aged plus 65, who are coming from a minority group in the US, let's say, are less able to improve their AI abilities in any models, be it biased, unbiased. I doubt. I think our hypothesis will give the expected results, but we'll have to see. The question is, how do you detect the bias? That's actually the tricky part. How do you introduce these biases? And that's where a major research will need to be conducted, which will take about 5 years. That's what we are expecting to spare for this research. Again, you asked a very brief question, but I just answered it for 5 minutes. I hope
Thank
that's
you.
okay.
I'm thinking about DARPA alchemists who fond of human social intelligence and reduce it to its algorithmic remains. That's what I'm thinking about. But thank you for your answer.
I mean, but I mean, so the question is then, how do we deal with that? Or like, I couldn't really get like what the question then is.
Bias,
The bias?
sorry about microphone. Fond of human social intelligence and bias. What do they want from this?
They want from this.
Uh-huh.
I would say, well, from a company's perspective, that would be profit maximization of some sort. There's another
And social engineering, maybe.
There's another layer to this. I mean, as you also mentioned, I mean, the investment in military, I mean, AI in military is actually something that we cannot overlook, particularly in the case of the United States and China as well, actually. And I mean, some other players also in the game, but these are the two major players. And there is what we could consider as public-private partnerships. These are very much state supported. And I mean, of course, whoever gets in the game early and develops the models and uses the technologies and disseminates that will definitely be the one controlling the game. But it's not the serious game, of course, the other game that you just mentioned. So
Yes.
that is going to be the driving motive for them.
Thank you. Thank you.
Sure.
Thank you so much, Hocam, for this amazing presentation. I am
Thank
stopping
you
the
all for
recording.
it.
Allah with us today. Albert Hoca is a professor at Utrecht University. I hope I spelled it correct, and also at Boğaziçi University. So without taking further time, Hocam, I am really interested in what you will be presenting today. So please, the floor is yours, Hocam.
Thank you very much. Thank you very much for inviting me, and I'm also amazed that so many people have been gathered here on a Sunday. Thank you very much for coming. I hope you will find it fruitful. I will talk a little bit about